Great. Good afternoon. Welcome to the fifth in the 2017 fall season of Sunoikisis Digital Cultural Heritage. This session is the second of two sessions on Geographic Information Systems, titled Interpreting Geographic Data. And the session is going to be presented live by Chiara Palladino, who will explain a little bit more about how this is going to work, and Masume Seidi, both from Leipzig. And we'll also be joined across space and time by Tom Elliott from New York University, and in the air above the American Midwest. But more on that shortly. So I will hand over to Chiara.
Thank you, Gabby. So I will just briefly introduce you to the purpose of this session and give you a rough overview about the contents, and then I will leave the word to Tom Elliott, who is actually joining us thanks to a pre-recorded part of the session that we're going to stream during this Sunoikisis session. So just to remind that Tom is not able to answer to any question that's made live for this time, but we will do our best to answer if you have any question. So basically the purpose of this session is to give you a quite accurate overview about different techniques of visualization that can help research on spatial data expressed in textual sources and documents, especially from the pre-modern age and antiquity. So because of that, we are going to give you an idea of the whole process, and this is going to be Tom's part, of going from a textual source, the Vicare lookups, that is actually geospatial by definition, because it is an itinerary that mentions several places connected by distances, and explain to you how the visualization of the data on a map. And we will see how to work with Latin place names with OpenRefine, and how to align them to Pleiades in order to retrieve the coordinates, and how to visualize them in a relatively rough way, but very immediate way. And then we will give you kind of a more sophisticated idea about the methodological aspects that are behind the process of visualizing data that actually need to be interpreted. And about the complexity of the process of going from data extraction to data visualization that is not by any means corresponding to the proverbial magic box of digital tools that will give you a wonderful map from a textual source immediately. It doesn't work like that, and I want to be very clear about it. And then we will present you very interesting tools. And this is going to be Masume's part, who introduces you to the second version of the Arabic gazetteer Al-Thuraya, and to a new tool for the visualization and contextualization of different kinds of interacting data. So I will metaphorically leave the word to Tom by streaming his contribution to this session. So we'll share my screen and activate my audio.
Today, we'll be working through a series of steps common to many projects in ancient studies. So, given a text, some number of objects, or some research data, there's usually a geographic aspect, and often there's a desire to analyze or visualize that geography programmatically. How do we get structured data for these geographic tasks? How do we move from a text or a list of places related to some objects or survey information and map it or do geographic analysis? Example, a really interesting set of objects called the Vicarello cups. The name is the modern one. We don't know what these things are called in antiquity. This modern name takes the Italian place name associated with the site of discovery, which is just north of the ancient Sabatinus Lacus in Italy. So you're to the north and west of Rome. In antiquity, this site on the north was what's called Aquae Apollinaris, a health spa and bathing establishment sacred to the god Apollo, fed by natural hot springs. These springs remained popular even after the fall of the Roman Empire, and in the mid-19th century, a series of renovations and repairs were conducted, and during that work, a large series of votive deposits were found in the spring themselves. This series of deposits included coins and other objects, many of them made of precious metals. Among these are the objects shown here. There are 4 of them inscribed with itineraries, and they're now in the Museo Nazionale in Rome. Itineraries are textual descriptions of journeys, usually land journeys, indicating major waypoints and the distances between them. For these cups from Aquae Apollinaris Novae, the itinerary in question is a land itinerary, and it's from Gades, modern Cadiz in Spain, so on the southwest coast of Spain, all the way to Rome. We're going to try to take the text that appears on one of these cups and move it into a structured data environment so that we can map it and could potentially perform some kind of analysis on it, say looking at the distance figures or something else. Introduce a number of tools and make reference to some other information that I've provided here. We'll get our text from the Electronic Archive of Greek and Latin Epigraphy, and specifically from the epigraphic database Roma, which provides information about Roman inscriptions from ancient Italy. We'll make use of 2 software tools, one called OpenRefine and the other called GeoCollider. These 2 tools will allow us to take the data we've created and to collate or align it with the Pleiades Gazetteer, which is an online resource for information about ancient places and place names. That process has been described in a blog post that I recently wrote on my blog, Orthosia, and I've provided a reference to that here for future use. So the first step in many projects is, as we've indicated, assembling a miniature gazetteer for the project. Ideally, this is a collection of structured data about the place names and places that are relevant to whatever the research question is. For our example today, working with the Vicarello cups, what we will do is we will try to make structured data for each of the places that are mentioned on the cups, and we can use that then for visualization or analysis. Fortunately, the text of the Vicarello cups has already been published, so we're in a position to copy that text for our own research purposes and then work it into structured data. The structured data that we're going to try to produce is not separated to a simple table, something you could open in a spreadsheet program or in a wide variety of other software. Through the process of collecting the text, making it into a minimally sufficient CSV file, and then adding some information to the CSV file that will set us up for the next step, which is trying to align it or reconcile it with a digital gazetteer that can provide us with coordinates so we can do some visualization. The Eagle Inscriptions Project provides access to and search of a number of different online sources of epigraphic material, and that's what we're going to use to find a text of the Vicarello cups. We'll go to their search page. This is to search for some distinctive text that's in the inscription. I happen to know that several of them include the word itinerary in Latin, itinerarium. So we'll search for that. 5 results. So we're going to scroll down and see this doesn't seem to be related. Inscription from Clodii, ab Gades usque Romam. Okay, so from Gades to Rome, an itinerary. This is one of them. The one I'd like to use for our purposes here, because it requires the least amount of editorial intervention, is this one. So we're going to click on that result. which takes us to the Eagle display. And what we really want to do is get to the original source. So we're going to go to the website of the epigraphic database Roma, which provides that particular text. And in fact, here we have the text. It's got a unique identifying number, but what we're interested in is the text itself. So we will just select that text from beginning to end, and we will copy it. We're now going to switch over to a text editor. Any good text editor should be able to support doing this. I'm using Sublime Text on a Macintosh, but there are lots of other choices, both open source and paid, and we'll paste in the text. Now, what we have here is some plain text that's got some aspects to it that make it a little difficult to use as ordered data, structured data on its own. The interstitial periodic introduction of line numbers is useful, problematic, and then also the column indications. But we can fix all that with a little judicious use of regular expressions. Regular expressions is a language for manipulating, matching and manipulating text. This particular text editor supports the execution of regular expressions on textual content, and that's what we're going to use. And our goal is to produce a comma-separated values file. We want 2 columns. The first column will contain line numbers, 1 for each line, and then the second column will contain the text as we have it. And then we can get rid of these column entries later. So I'm going to invoke the appropriate section of this. And the first thing I want to do, I think, is to match any line at the very beginning that has 1 or more digits beginning that line. So that's going to capture our line numbers. And these can have some space after them. And then I'm going to produce a new line that repeats the number we've matched, introduces a comma and a space, and then the rest of the line that wasn't matched will be copied in. So here I have now intervened in those lines, like this first one, and we've got a comma, which is the delimiter we use in comma-separated values. Now I need to introduce a comma at the beginning of each line that does not have a number in it, so that we can avoid having these things be in the wrong columns. So here I've made an expression that matches any column that begins with something other than a number. And you can see it's picking up those initials, but not the initial of that line. And here, since we don't have a line number indicated, we're just going to put in a comma, which will cause a blank cell to appear in that column, and then we'll reintroduce the rest of the line. There we go. We are now ready to treat this information as comma-separated values. So we're going to save it into a convenient directory. I think we should give it a name that will help us remember where we got it from. In this case, the EDR number. And we are going to give it the CSV extension, so we remember that it's comma-separated values. We can now dispense with our text editor. And what we're going to do now is open up this file in Libreoffice, which is an open source Office application and one that understands how to read CSV into a spreadsheet. That will give us a spreadsheet view that we can use to make more changes. Here we go. It's correctly identified the structure of the file. And we will bring it onto our screen. And here we have the data. First thing we want is a header. We're going to introduce the 2 columns, line and text, and then we're going to add a 3rd column, place name. So this will be the place name drawn from the text on that line that we want to do something with in terms of our research. We're also going to take these column headers and turn them into another cell of data at the beginning of each line so that they're not in the way and they're not getting confused with text. And so when we work with our data later, we always know for a given entry which column and which line the item came from. And now to make things easy to read, there we go. We're going to save this as a separate file so we don't write over what we're doing. And we're going to change the name appropriately. LibreOffice likes to warn us that there are kinds of things in spreadsheets that won't save into CSV, but we're okay with that. We know what we're doing, so we're going to proceed. First thing we need to do is get columns. There is a useful function in most spreadsheet tools called fill that will repeat a number in the first cell into all other selected cells. This quickly lets us associate the column number we note there's a keystroke for doing it more quickly. Now we have a column number for each line, so we can get rid of the lines that were functioning as headers. Now we want to get line numbers everywhere they belong. We'd like to fill with a series, and most major spreadsheets have an easy way for doing this. You start with your initial number, and then you click and drag the little handle on the selected cell, and that fills a series into the cells. Now, for each and every line, we have a good reference to what column number and what line number in the original text that line came from. The next thing we need to be able to do to work with this information as structured data in a spatial context is to extract the place names from the data. And this is where we need to pay a little more attention to the text itself. We'll notice that the majority of lines consist of a place name and then a number using Roman numerals. These place names are interpreted to be the major stops along the itinerary and then the distances associated with them. You'll note that the units are not indicated. There are a couple of other lines. This first one, Itinerarium Agades Romam, and the last one, Summa Milia Passus, which are not just place name number. Itinerarium Agades Romam is a heading or an introduction or a title. So it's not properly one of these lines. And then the final line is a summation of the numbers of Roman miles. And here we're actually given the units, milia passus, that the whole itinerary requires. One of the characteristics of the names in the major lines of this inscription is that they tend to be in the accusative case. This is one of the challenges of dealing with an inflected language and place names in an inflected language, which is that you will often have to normalize or make those names nominative. You can run into other problems trying to identify place names as well, but that's the first one we have to concern ourselves with here. In the first line, Gades is not a problem because of the way it declines. In the second line, we have a prepositional phrase with the preposition odd that functions as a place name, and odd takes the accusative, so we're not going to concern ourselves with that. But here we have hastam, which is an accusative of hasta, ugia, or ripus probably, hispalis, carmo, and so on. And we could work our way all the way down this list, sorting out what the probable nominatives are. But we're not going to do all of that in the interest of time today. So we will save this CSV file, and we'll move on to the next phase in the process, which is using the OpenRefine tool to align or collate our data set against the Pleiades gazetteer. Let's collate our Vicarello data set against the Pleiades gazetteer of ancient places. To do this, we'll need two tools. The first one is called OpenRefine, which is a tool for working with tabular data and cleaning it up and enhancing it. And another tool called GeoCollider. GeoCollider is a web service written by Ryan Bauman at Duke University, and it's designed to work with OpenRefine. What it does is it takes some of the Pleiades data set and makes it available for queries designed to match up place names with the identifiers that Pleiades uses for the individual places. OpenRefine runs as a local server. Once you've installed it, you fire it up as you would any other application, and once it's up and running, it's going to open a window on your computer. In the preparatory material for today's talk, I included a link to a blog post I recently put up about how to do OpenRefine with Pleiades, and it provides information on download and installation and so on. So I thought I'd alert you to it here. We're also going to use some of the code snippets that are in it for our demonstration today. The first thing to do in OpenRefine is to open the file we've created. The standard process that should be getting familiar, where you're shown a preview, you're asked to verify character encoding, give your project a name, all that sort of thing you've seen in various kinds of programs that deal with CSV and other data formats. Here's our data chunked into nicely helpful amounts. What we're going to do is we're going to ask OpenRefine to work with GeoCollider to look at these place names and try to find possible matches in Pleiades and then present them to us so we can do things like get the latitude and longitude for those matching places. The term of art used by OpenRefine is reconciliation. So we go to the reconcile submenu on the place name column and we start reconciling. We're asked to use the Pleiades reconciliation, which is uses GeoCollider. This is something you'll have to set up the first time. It's very easy. The blog post shows you how. Once the service is up and running, we leave all the defaults as they are and we say start reconciling. Depending on various settings, this may take anywhere from a couple of seconds to a couple of minutes, but the result will be that we're presented with various options for each of the places. So here we have only one match for Gades. That's Gades itself. That one's not problematic. We can just say, yes, that's the one we're talking about. I've reconciled and matched that particular one. At Portum might present a little bit more of a problem, except that one of the alternate names for the port of ancient Gades includes the name Gades. So it's really quite obvious if we're beginning a trip from Gades that we might go through the port. But then we come to Hasta. Which Hasta is meant? Well, the only way we can be sure is to have a human go look at Pleiades, and that's easily done by transiting the link provided by OpenRefine and GeoCollider. I'm going to open these in a new tab so I don't lose track of where I am. Here's a Hasta that's in northern Italy. I don't think that's our target. Here's one that's in coastal northern Italy. I don't think that's our target. But here's one near the Bay of Cadiz. This is probably our target. We're going to go ahead and assume that it is and click the corresponding checkbox, which matches it up. The other examples where we have matches here are not problematic. If we were being disciplined, we would check them all to make sure that we agree with the choice we've been given, because things can go wrong. We would be a little surprised by Euripus that we haven't got a match. I'd have thought that would be in Pleiades. Maybe we need to go look for ourselves. Maybe something's gone wrong in the GeoCollider process or with our data. Pleiades knows about a place near the Bay of Cadiz that is called Oripo. Could that be our target? Quite possibly. Maybe we've stumbled on a source that uses a different declined version of the name. Maybe we've mistakenly supplied the wrong nominative since we were in a hurry doing that part of the work. Maybe there's some mistake in transmission of text. These are all concerns that can arise. In any case, we could go back and modify our data set, run reconciliation again, and get a better result. Or we could just add that information to the data set directly in OpenRefine. Worth raising right now is that OpenRefine doesn't have to be the only tool you use for this. Some gazetteers don't support OpenRefine. You may have a situation where you have a few enough items that you can go to the gazetteer you're trying to match and look them up by hand and copy and paste. There's lots of ways to do this particular reconciliation task. The important thing to remember is that there almost always needs to be some human supervision of the project and the process, some checking of the results, and probably an iterative approach as you learn more about your data and about the gazetteer you're aligning to. We'll move on at this point and go ahead and try to get the latitude and longitude for the places we've already matched. What we want to do is get a link not to the individual Pleiades entries for particular places, but to a structured data version of them in the JavaScript object notation, or JSON language. This bit of information we're after is specifically the so-called representative point, which is calculated by Pleiades based on the detailed location information that's there. And it's simply a named object in the JSON that is a list of two elements, the longitude and then the latitude. You need to make note of the order in which they appear. This is in accordance with a particular standard that places the longitude before the latitude. Pleiades puts the JSON information at a link that is simply the Pleiades ID or the Pleiades Uniform Resource Identifier with the postfix JSON. You can always get it that way. So we'll tell OpenRefine that we want to create a new column based on this column. We'll call it the JSON URI. And what we want to do is use the reconciliation match. And to remember the syntax, it's the ID. And then we want to add that little string /JSON. So here's an example of what we're going to get. Boom, there we have our JSON URIs. It's at this point that we could add Euripus if we wanted to, but we're not going to take the time. Instead, we want to actually direct OpenRefine to visit each of those JSON pages on Pleiades and pull that information down here so we can do things with it. This is done with edit column, add column by fetching URLs. We're going to create a new column and we're going to fetch these URLs directly into the column. The easiest way to find Google Fusion tables online is to use the Google search engine to look for the help page, and then there's a convenient link there. It's a little bit less obvious than some other Google services because it's a so-called labs or beta piece of software, and so is not always obvious how to get to. Here's that help page. And I want to go straight to creating a Fusion table. It's pretty simple. You upload your table and then you look for a map. How does this work? Well, you choose the file. Here is our file. Google has figured out its comma-separated value. It's detected that the character encoding is UTF-8, so we're going to move ahead. It's having a quick look at the data and showing that to you, and it looks like it's properly parsing the commas and so on. And finally, it's going to ask us for a name. They want to know if we will let other people export the data and so on. And we're going to just move past that step to look at our data. One of the reasons I wanted to use Google Fusion tables to take a first look at visualization of this data was because it's designed to give you a map if there's a latitude and a longitude column in the data set. It's just built in. So all I have to do is have a latitude and longitude column. I've loaded this data in. I click on the Map of Latitude tab, and I'm presented with a map. It's got modern topography and place names and so on in it, but it also has my data right here. Here's the beginnings of our itinerary headed toward Rome. The map is set up so that it will display a little pop-up with the rest of the content of your data. The fact that the JSON is in there makes it a little messy. We can always change the info window to leave out the JSON, so that's a little bit less distracting. And when we're done with it, we can browse the map, we can show it to colleagues, we can decide if we're really getting the basic geography right. And then we can go on to other tools to produce other kinds of visualizations, to do more analysis of our data, now that we've had this first kind of visual confirmation that it's in good shape. That's a very quick look at a basic workflow for getting some data related to a particular text or a particular set of research questions into a structured format that can be mapped quickly. We've elided a number of concerns about data quality, about accuracy of coordinates, about precision of coordinates, and so on, but the basic workflow should be clear, and other tools can be used as appropriate.
Okay, so this was Tom's contribution to this session. And before I can introduce you, Massimo, I will share again my screen and start our presentation just to give a little bit of a conceptual introduction to the rest of the session. There we go. So again, the entire point of Tom's experiment as well with apps is to propose a workflow that in any kind of geospatial visualization from historical sources is more or less agreed on. And this kind of workflow has several steps that we have more or less summarized here. You start from any kind of annotation, which can mean to use any kind of tool for annotating data. If you were here in the previous sessions, you have known a lot of tools to annotate special references in texts. You can retrieve directly toponyms from the source. You can retrieve any kind of other textual information that has some kind of spatial content in it, like divisions or routes or distances and so on. Then there is a second step, which is a disambiguation. That also Tom has shown you in case the toponyms are individuated in multiple kinds of locations. In that case, there are instances that can be very difficult to solve with automated approaches. And ultimately, the intervention of a human who really knows the source and who knows the context of that source is very important in order to associate the toponyms to places that are actually the places to which the source refers to. Then, of course, there is the step that is called georeferencing, which is essentially assign coordinates to the places that are mentioned in the source. And the immediate step that follows georeferencing is obviously the visualization approach. So the problem with visualizing spatial data that were not meant to be visualized because they were in textual shape is that there is actually no golden standard to visualize a historical source that is expressed in textual form. And the bottom line of Tom's intervention was that visualization is actually iterative. It's not one direction process that goes from the data to the visualization and has no kind of going back to the data, no kind of contextualization, no kind of human intervention in it. It is actually a process that requires multiple close reading to the source and multiple stages of going back to the data and try to know them a little bit more and try to understand what they mean for their cultural context and try to understand what kind of connections that kind of data can establish with the different models and visualizations that we have. And I'm not using the plural casually because there can be different kinds of visualization approach according to your interpretation of the data and according to the particular type of data that you have to do with. Of course, if you have an itinerary like the Career lookups, you may want to be interested in visualizing how that kind of itinerary goes on a map, which kind of progression there is in the line that is established between different places. But if you have to do with a different source, like a source that describes a particular administrative division or the political connections of a big city with the rest of the hinterland, you may be interested in visualizing the kind of connections that this place establishes with the rest of the world, with the rest of the region, and so on. So again, there is no magic box and there is no perfect approach to the visualization. It's always an iterative process that requires you to know your data very well, to know what you want to see, and to go back to the data in case the visualization needs to be contextualized and needs to be perfected. The cool thing about visualizing things is that visualization can suggest to you different kind of research questions from the ones that you started with. And this is the real importance of trying to visualize a textual source that was not made to be mapped, to be visualized. And now I will probably leave the word to Massimo, who is going to talk about a different kind of process of data extraction and data visualization and show you a sophisticated visualization approach, just to show you what can be done when you have a massive amount of spatial data that are semantically characterized and what kind of visualizations you can have.
Okay. I'm sorry. Yeah, okay, following Chiara's explanation about how we deal with textual sources and how we strategically use them in order to model and visualize for further studies, I would like to give more details in the starting point that we start annotating the sources. What we use here as an example of inline annotation, we use OpenRefine Markdown, which probably Chiara has talked about it before. We can tag any type of or piece of information inside a text. What we focus here to give more details is that analytical patterns which describe geographical information in terms of like administrative divisions, hierarchical divisions, and route network. For this hierarchical division, we followed a pattern of a division which follows the major provinces of a ward. I mean, ward means that the area of what you're working on. And then trying to divide it into subordinate regions down to the settlements. So following this pattern, we introduce a way of producing triples of tagging schema, which means that we have provinces or regions divided into subordinate regions or settlements, and they are connected to each other through a type, which is practically described in the source. And what we do is just simply to preserve the vocabulary. So this will give us the triple of subject, predicate, and object, which we can produce toponyms related to each other. Sorry, toponyms related to each other through a type. So this type defines how this division works. I mean, what is the type of this division? So here you can see that, for example, the major province here is divided in 4 level 1 regions with a specific type, which we can get it from the text. And then this region here has its own settlements as a capital. Again, the type is taken from the source, and it has its own other type of settlements, which is like major cities. And for the route sections and distances, again, we use a pattern of triples from a place to a place with a specific distance. So this will also, again, connect two toponyms with a specific distance, introducing a new connection or a route section between 2 places, which is described in the source. So here you see that from a place to a destination to another place, we have a distance of a stage. And following the same way, so we get from this destination to another one, we have another stage to go. So these all lead us to extract the data in triples, which is semantically cutting down the whole descriptions into an abstraction. So here you see that we have pieces of information from the whole descriptions in the form of triples, individual pieces of information. And what we can do with these lines or triples is to computationally connect them to shape the whole idea behind. So for example, if we put the triples regarding the hierarchical divisions together, we can get a line like starting from a province down to a settlement, having all the information between. So this line shows that a province is divided in a region with a specific type, and this region has its own subordinate region, and the second level region has its own settlements. So this is where we start, I mean, after extracting data, where we start doing computational approaches to produce data behind. So at the end, for example, you can see that how we can form those little pieces of information into a hierarchical form of visualization, which starts with the root and the major provinces at the first level, the second level subordinate regions in any number of the levels, And at the leaves, you can see the settlements. So this is what we get from a description of a text. So I would like to give you some examples of how we visualize regions based on the descriptions in the sources. Actually, the descriptions does not have any visual perception. And what we do is that we use computational ways to see how we can fit to the textual description. So what we did in our experiment is that we tried different ways of visualization of hierarchical data. This is just for one level. I mean, all the examples here that I give are for one level of hierarchy, but it can be generalized to different levels of hierarchies as much as we have. So here, for example, you see the approach of quadtree that we use an algorithm behind, which space is partitioned into 4 cells in each level, and each cell it gets 4 more cells. I mean, it's divided to 4 more cells further and further until we can put individual settlements or places in individual cells. And as you can see here, we have different circles, which the smallest one shows the smallest places like settlements. And when they get bigger, it means that they are, I mean, the cells are combined to shape bigger circles. So the bigger, when you zoom out more and more, so you can see how the bigger circles can offer regional representation. But as we discussed, the type of, I mean, the description of the hierarchical division, this is not the way that it's described in the sources. And this way, this visualization is good when you don't have such a description in your source. Since we have this this type of description, we have tried some other ways. For example, trying Voronoi diagram, which is again a space partitioning algorithm, and it puts actually defines the partitions around the place based on the distances of each point in a partition to the central point, which actually is our settlements on the map. So the big partitions here are actually cut down, so cut out, so you don't see any, I mean, you might see that some places are not in a specific partition. And you see here that we have points, multiple points in specific color. So you can see that those belongs to a specific region. But to make it more practical, what we can do here, since we have here, but by this algorithm, we take the whole earth as the working area. So we can cut it in a way that it limits to our working space. It means that we have cut it with, here we have cut it with a big convex hull, which include our settlements inside. And to make it more efficient, we have cut it more with convex hull of each region. It means that instead of cutting just by outer polygon, we can cut the individual places to get rid of those spaces that are deserted and they practically do not belong to any specific region. So you see here that we get some, I mean, some spaces out of the regions. And the other way that we have tried is simply to just forget about the Voronoi diagram and produce convex hull of each region. You see here that we just get a simple divisions and visualization of each region, but the point here is that we get some overlaps here, which is practically not what we get in reality. So to fix this, we have tried concave hull of each region instead of using convex hull. So you see here that we get more nuanced shape of each region. So it's just look at the Egypt here, for example, which is compared to the other one is much better. But still, we have some areas which we have to eliminate. I mean, we don't really need them. I mean, the Egypt was just a narrow line along the Nile, so these strand shapes are not really what we can represent Egypt. Or you can see still that some water bodies are still covered by regions, which is not really what we can connect to the or represent the source through. And what we offer at the end, which in fact we are using also in our gazetteer, is representing the regions by using places and route sections over the network of each region, just by assigning them a single color. So here you can see that we are showing the extent of each region in the space, and we don't really have any other problem that we had with the other approaches. What I would like also to talk about a bit is our gazetteer, also your gazetteer, which is based on the first version of this gazetteer at Tufts. And this is actually, this is right now holding data from Geographical News Atlas with over 2,000 toponyms and route sections, which is in fact georeferenced from this atlas. And it's actually a bit, it provides what the gazetteer provides, like you can see technical information about the place, all the names, translation, latitude and longitude, the region it belongs, names and the other languages. Here is Arabic, only for the dataset that we have, together with transliteration. And you can see information from primary sources related to the toponym in question. You can have access to secondary sources. It means that it's providing a connection to data. So you can, for example, for this one, you can have access to Encyclopedia of Islam or other major secondary sources available. You can see extent of regions and the space by having them highlighted. And you can search for different toponyms and have a list of simply suggestions. You can see information on route sections, the distances, start and end, and how they are connected geographically in terms of latitude and longitude. Another feature which is provided here is pathfinding. So you can search for a path from a source to a destination, and having the options of shortest and optimal paths. It means that based on the descriptions from different sources, and based on the distances and the condition of the travel, it can, if there's a short path which is probably not safe enough to take, you can also have the option of another optimal path. For example, here you can see that from Damascus to Baghdad, the shortest path is to go through a desert here, but since it's not safe to survive, you can take another optimal path, and the route sections is in a way that you can survive during the night and then travel during the day. So it means that the green line is safer, even though it's not shorter. And you can have more information about like the distances, average distances, and so on. Then for pathfinding, you can also shape an itinerary, starting from a point, some stops between, and just getting to this destination with both optimal and shortest path. And another part of this gazetteer is, which is actually an interesting part, is the network plot, where you can shape a network starting from an arbitrary point or even multiple points, and shape a network with a multiplier, which means that it shows that depending on the multiplier, how you can reach the network connected to this place. For example, if you choose Baghdad as a center of the network and you want to see how reachable is the other cities from Baghdad in 5 days, which is the multiplier, you can see that the red zone shows that all the places which can be accessible in the first 5 days, and then the orange circle or orange zone shows that the next 5 days, that those places that can be accessible in 10 days. The yellow zone shows the next 5 days, and at the end, the furthest zone in green shows that reachable points in the next 5 days. So you can also do this with more than one starting point. And this is a good example of showing that how an area can be accessed through a certain place. For example, if a dynasty is going to conquer some area and choose a capital, you can follow that how the other places are reachable through this capital place. And yeah, all these works on this gazetteer on Al-Thuraya is done based on the data set, and this is in fact an ongoing project which can be applicable to the other data sets. But what is important here is that we provide some ways to have this data from the sources digitized and using computational methods to use them as tools for studying the source without referring to text for each time that we want to see a specific place or the connections, or how close they are, how reachable they are, or how they can how they shape the whole area, and in general to study the history. And the other example of using this kind of abstraction and combining different type of data, which is actually based on the geospatial fundamental that we provide, is exploratorium, which is in fact an actually explanatory tools which give you the opportunity of going through different sources and trying to study different aspects of and connections and of information related to people, time, and space. It means that we combine those together based on the geospatial infrastructure that we have provided. So to give you just some examples, here you can see that for connecting individuals on the space, you can select a descriptor of an individual and see how different descriptors of individuals are related to the space in two different macro and micro regions. So here you see the settlements in micro level, and you see the regions in macro level. You can see the changes over the time. You can have them animated, and you can see how is this connections numbered through the map. And the other part of this exploratorium is time. It means that you can see how individuals through the time are connected to each other. And you can see that how in the primary sources, they are referenced through the time. So on the left, you can see the changes over the time for the selected individual, and on the right, you can see the most frequent individual to the selected item. It means that Dimashqi is the most relevant or most corresponding one to Qurashi, which is our selected item, and you can see the all other corresponding individuals as well at the bottom. And you can also have a look at the network of entities which this item is connected to. So it means that this item, the item in question or the individual's question is connected to which information which represents time or year, and also a place, plus that the other individuals. So you can see all the connections to the item in question here in the graph. And the main part of this this exploratorium is the article, or I mean part of the primary sources that the data comes from. To have a chance to look at the primary sources related to the selected item, and then go through them and yeah, just to simply read them. Right now, this exploratorium is based on a major historical source called Tarikh al-Islam, History of Islam, from al-Zahabi. And but what we are doing right now is to introducing more general data structure behind, which is applicable to practically any other primary sources or even secondary sources, which you can see, for example, from an online libraries or any kind of encyclopedia. Which you can access articles, and you can see the relations between place, time, and people. So here I stop and leave to Chiara, which is going to describe the exercises right now.
Okay, thank you, Massimo.
Let
So,
me,
share my screen again.
yeah, let me.
Okay, so in the last 10 minutes, I will try to give you a very, very short overview about what you're expected to do for the exercise that we proposed. So this time, we decided to give you two options that are structurally different in terms of what you can do with any kind of textual source that you want to visualize in different kinds of frameworks, let's say. So the first thing that we propose, the first option, is to visualize a text with QGIS, which I know many of you have already installed. And I will just go through the way that you can upload a file into QGIS very quickly, just so that you're not surprised in what you can see in the program. So QGIS, you're expected to download it and to install it. And once you get to the first page of the tool, you will open just a new project and be sure that you have all the correct plugins installed. In this case, we will need a map layer, of course. So you will need to install the so-called Open Layers plugin. So you will just go to Plugins to manage and install plugins if you already don't see the Open Layers installed. And you can just look for it into the search bar, search for Open Layers, and install it. Once you have it, the first thing that you're going to do is to try to have some kind of map where you can visualize your data. So you will go to Web and install and visualize the Open Layers plugin. Open Layers plugin will give you several alternatives of maps that you can see. In this case, I choose the Google Satellite map layer just because it looks cool, honestly. It looks like this. Then the next thing that you're going to do is to upload a file. And most of the files that come from textual sources mentioning spatial data, as we mentioned, are basically delimited text layers, which means essentially text in tabular format and in CSV format. So you will choose layer, and add delimited text layer. It will open you this kind of scary view, which is create a layer from a delimited text file. Don't panic and just go to browse and try to upload any kind of chosen file that you have in the CSV format. What it will attempt will be to recognize what kind of separators and delimiters your file has, and to identify automatically what kind of data it contains. There's just a couple of things that you need to pay attention to in this case, which is, of course, the file format. If it doesn't recognize what kind of file format it is, you will need to choose custom delimiters, which will open a different view that will ask you what kind of custom delimiters you wish to set up. And it can be tab, it can be a different kind of CSV delimiter, it can be anything. Then you will need to pay attention to, there you go, you can choose the semicolon, you can choose the column, the space, and so on. The other thing that you will need to pay attention to is the record options. In this case, it depends whether you choose a header for your file or not. In the first case, you will need to set up the option first record has the field names, and it will show you a little preview of what the file will look like. And the third thing that you really need to have attention to is the fields that indicate the longitude and latitude. As Tom mentioned, there is a convention that establishes to have the longitude first and the latitude second. So you will need to set it up. Then the other important thing is to use the filter option. You will need to set a specific coordinate reference system, which is the 4326 EPSG. You can just look it up into the coordinate reference system selector. This is the second view that will open just once you upload your layer. And the magic, you can see all the places that are mentioned in your text just uploaded on the map layer that you selected with no further steps. And again, you can style your map according basically to what you want to see and to how your particular file is shaped. So, of course, one of the things that you may wish to is to have a label for all the places that are mentioned in the file, in which case you will need to know where the names of the places that you have are located in your original file. So you will need to set the labels according to the particular column where they are located in your original file, which of course you will need to know. Of course, depending on the number of the places, it can be more or less chaotic or not, but that again depends on what you want to see. The other option is to have a categorized view according to the particular kind of classification that you have in your file. And again, you will need to know your data very well in order to know what you want to see. So in this case, for this little experiment, I used the CSV file that you can download from the Roman Amphitheaters project, curated by Sebastian Heath, that basically gives you an overview of several data connected to attested Roman amphitheaters. So this kind of categorized view is particularly interesting because it gives you several options for classification. One that can be interesting is to see all the locations of the amphitheaters classified according to the province. And you can style that by clicking on classifying. What it will show you is, again, a little preview of the legend, the label of each province, and the color to which each province can be visualized. And then, of course, you can have several types of stylistic layout, stylistic options. You can choose a selector, you can choose a color, and so on. What will end up, it will be a nice classified view of all the provinces and of the locations of several amphitheaters colored according to the province. Of course, you can try to select the view according to the emperor. I also chose to style the selectors differently in this case. You can select the view according to century if you have any kind of periodizing information, according to the unidentified kind of places that you have. And of course, you can select according to the capacity if you have the kind of data. And of course, as Massimo mentioned, there are also different kinds of algorithmic views that you can set up that is a little bit more time consuming. But of course, if you want, QGIS offers the possibility of having visualized the orthogonal polygons and the convex hulls in order to retrieve the regional areas from the data you have and nothing else. The option 2, which I will go through very quickly, is to map the spatial indications of an itinerary on Orbis. So Orbis is basically a tool that allows you to measure and to calculate an itinerary between 2 or more places according to different kinds of conditions where travel occurs. And it starts from the very easy theoretical premise to understand for antiquity that in antiquity travels happened in very different kinds of conditions than in modern times. So of course, the cost of a certain type of itinerary depended on the conditions of that itinerary, in which season it happened, at which kind of priority it happened. It depended on where you were in a military side or whether you were a civilian. It depended on the kind of network that connected the places you wanted to visit, if it was a maritime network, if it was a road network, and so on. It depended on whether you wanted to go there by foot, walking, if you wanted to go there by sea, what kind of sea route you wanted to achieve, and so on. And the functioning of Orbis is relatively simple to understand. It will offer you a calculate route view, where you can choose the place where you want to start with and the place where you want to go to. So you can select any kind of place that you want that's already in the database. So in this case, you can choose Rome. And it will show you different kinds of options according to the type of itinerary that you want to have. You can choose the type of priority, you can choose the kind of breadth of network that you want to have. You can choose even the mode. So whatever you want, it will select for you the kind of easiest path. Once it has selected a kind of easiest path, you can combine several itineraries to see how they interact together. And of course, according to clicking on the several intermediate stations that it will propose to you, you can also decide to delete that kind of intermediary route and choose another one by clicking on exclude site. And that really depends on you. It depends on what kind of itinerary you imagine it happened in your source. And this may be an interesting experiment to go with the Vicarello cups. In the exercise overview that I mentioned before on the Sunoikisis website, I have given you some links where to retrieve from the text of the Vicarello cups. You can also use the EDR epigraphic database Roma link that was shown you by Tom. It's pretty much the same text. You will just go copy it and select the various places and try to retrieve some kind of itinerary from them by using Orbis. So I think that we really run out of time. So, and I am really just a silhouette now. But I will just open the field to a very quick round of questions and then.
Thank you, Chiara and Masume. That was a really useful, if very fast overview of some of the technologies and some of the approaches that you can use and some of the tools that you can use with geographic material. I've just been looking on YouTube and elsewhere. No one has written any questions there, and since the Hangout only contains 3 of us, the usual Sunoikisis group are, for unrelated reasons, all elsewhere. There's no one else asking any questions. What I might suggest, rather than going on any further immediately now, unless either of you have any questions for each other, would be simply that if any of the students watching this session, not in real time, have any questions that they would like to ask, that they could maybe get in touch through Sunoikisis or through me or whoever their local tutor is, and get in touch with you with any questions that way. Would that be okay? Would you both be up for that?
Yeah, absolutely.
Great.
Yeah, sure.
Cool. Great. Then thank you both very much. I was particularly pleased that this session talked quite a lot about various approaches to munging data, as well as visualizing and querying that data, because next week the session is going to be about structured data more generally and about various ways of using that. So that'll make quite a good link to that. So thank you very much, both of you, again, and thanks to Tom, who's in a different time zone. And hopefully see you all next week. Thanks very much.
Bye.
Thank you. Bye.
Cheers. Bye.